Hello, students. So many of you have probably heard the story of Schoolboy Gauss, little boy that's in the classroom and his evil school teacher doesn't want to teach that day. So he just tells the students to add up the numbers from 1 to 100. And Gauss writes the number on his slate and shows him immediately. And the teacher's all mad and pulling out his hair. And it didn't really happen. Uh, but let's solve it using Python anyway. So what would happen if we did want to add the numbers from 1 to 100? Well, I mean, one thing that we could do is we could actually do that, right? We can write out each of the numbers and add them together, though that wouldn't be very nice. So we might think that Python has a way of uh, doing this that's a little easier, and it does. We have a function len that tells us the length of a set. We have a function sum, which tells us the sum of a set. It also tells us the sums of other things. So when we get to lists and generators and other stuff, we can use it there as well. But first things first, let's use the sum function to figure out the length of the set of the numbers. To figure out the sum of the numbers 1 through 100. So first, let's make the set. So how would we make the set? Well, we could do the set of all I for I in range. Let's go from 1 to 100. Okay. And if I hit enter there, I get a very long list here. But I'm not interested in the list. I want the sum of that. So let's stick that into sum, open parentheses and close parentheses, and see what I get. And I get 50/50. Which is the famous number from the fable. Okay, so SUM works on all sorts of things. You can use it for tiny little sums. What happens if I actually do this? If I do that, I'm going to get an error because sum gives me the sum of a thing. And what I did is I gave it 3 things. Now, if you read down here and you look at the error I got, it says sum takes at most 2 arguments. Now, I just told you sum gives you the sum of a thing. Why would we take in 2 different things into sum? So let's try and do a little bit of investigation. What happens if I type help sum? So what this is doing is it's saying, okay, I have an iterable, but I also have a starting number where I'm starting the tally at. So suppose we have an existing tally, right? And we're up to 50 already. So I want to add, I don't know, 3 more numbers. I know I'd be pretty lazy if I couldn't add 3 more numbers to 50. But what I could do is I could do start equals 50. And what this will do is it'll add those 3 numbers to the thing that I have, which is the start value. And if I do this with just this, I still get the same thing. So we're not going to actually use this a lot. I just wanted to explain to you what this error is saying. Because the error is giving me a lot of information saying, hey, you give me 3 things. I only take 2 things. Why does it take 2 things? It doesn't need 2 things, but it takes up to 2 things. And if you give it 2 things, what it'll do is you have to give it a number to start with. So it'll start with that number and the thing which is the collection, which is all the stuff that we're going to be adding. So that's how sum works. For the most part, we won't be using this. Maybe sometimes, but for the most part, we won't be using this. So let's say I wanted to know the sum of the squares of the first 10 positive integers. So I could just do this, x squared for x in range 1 through 11. And that gives me the sum of the squares of the first 10 positive integers. Let's do another example. Let's do the sum of a minus b for a in range 3 for b in range 3. And I get 0. Let's think about what's going on here. So if I look at this set, you'll notice it only has 5 numbers in it, not 9 numbers, right? We get 3 values of A and 3 values of B, but this is a set. So when we don't include any sort of repetition. So for instance, when A is 1 and B is 2, or when A is 2 and B is 1, we're not going to count that twice in our set. So what this is doing is it's just adding up these numbers once you've already reduced it by collapsing it, by removing all the repeats. That's what this here is doing for us. Now, suppose I wanted to now switch things up a little bit, and I want to do sum of a squared minus b squared. And this is still 0. Let's take a peek at the set. So the set's grown, but we still have this nice symmetry. For every positive, we get a negative because, hey, A and B are in the same range. So there's a lot of cancellation. So if the one thing I wanted to say here is there's two different questions. One is you could say, okay, what is the sum of a set? And the other thing is, what is the size of a set? For size of a set, we want to stick to LEN. So what I could do is I could stick this in here. And what it'll do is it'll tell me how many different elements I have, which I can see here. I have 1, 2, 3, 4, 5, 6, 7, and this is giving me the correct amount. So keep in mind the size of a set and the sum of the set are not the same thing. And LEN will give us the size of a set. SUM will give us the sum of a set. And I think that's all I need to say for right now about sum. As we move on, we're going to actually learn that we can use sum to find the size of a set as well, but not by putting set brackets inside sum. We're going to be able to sum 1 repeatedly, which we can't do now because sets don't allow 1 with repetition. But we'll see how we can do that later on.